Hi students, and hope you enjoyed my previous video, right? So if there is any comments are invited, right? So I am ready to accept your comments as we do in your class itself. So what we do now is we will introduce the semiconductor on atomic level, right? So semiconductors are the materials, as I told you, it shows conductivity or resistivity between conductors and insulators. Right? There are classifications of semiconductor materials. Right? In general, we will let's first look into the idea of what is in the semiconductor by atomic level. Right? So, if you take a semiconductor atom, obviously all the materials in this world are made up of atoms. Right? Atoms are made up of electrons, protons, and neutrons. You know this very well. You know these things very well. So now let's see how the semiconductors are there. Semiconductor atoms are there in semiconductor materials, right? So in semiconductor, there are certain materials or certain atoms like carbon, silicon, and germanium. Okay, these three are the major semiconductor materials. In particular, we use only silicon and germanium. Carbon has some more properties to discuss, but we don't have the scope of that in this subject. So we will discuss silicon and germanium, right? So if you take the electrons, number of electrons, in particular the valence electrons. Valence electrons are nothing but the outermost orbit of the given atom. Okay. Uh, say if you go see the atomic arrangement of the silicon and germanium, you can find one thing in common. The thing is, if you take a valence orbit, the number of electrons in the valence orbit is 4, right? If you write the electronic configuration, go through the internet, and you can find the silicon electronic configuration, you can see there will be 4 electrons in the valence orbit of an electron. Similarly, if you take germanium, that also have 4 electrons in the outermost orbit. Okay? So if you have large number of silicon atoms, what happens is the silicon atoms form or bond itself with the help of a bond called covalent. Okay, so covalent bond. What happens in covalent bond? And there is a mutual sharing of electrons between two atoms happens. Okay, so not only this bond shares the atom, it also stabilizes the silicon atoms, okay, which makes the material more stable. That is, stable means it doesn't get evaporated or it doesn't degrade. Those things are stabilized with the help of this bond, and which makes them to stable. Okay, so this is the common thing which you can observe in semiconductor materials. Right? And the another thing which you have is the classification. That is the types of semiconductor materials. So in general, depending upon the impurity, we can classify two types. One is the extrinsic material, which is doesn't contain impurities. This is the pure form of semiconductor materials, right? And another set which you have is the extrinsic semiconductor materials. So that contains impurities. Okay, that is impurities in the sense it is not something you are not so you are putting into that material. There are certain materials which is added to the pure semiconductor material in order to enhance the property of that semiconductor. Okay, so if you get into the charge carriers, that is the carriers or the charges which help us in uh, conduction in semiconductor materials. There are two types of carriers, charge carriers. One is the electron and holes. Holes are not a new kind of charges. They are the places where the electrons are absent. So that is what the holes. In general, by convention, electrons are negatively charged particles. The absence of electrons, which we call it as holes, we consider as positively charged. Okay, so that is the case. So you have to remember this thing in mind. Okay, so as I told you, intrinsic or pure semiconductor material, extrinsic or impure materials, or the material which has a dopant. Dopant means there are very few amount of impurity can be added to the pure semiconductor material, which help us to alter the properties, or the if we want to get certain properties as we design, right? So then we have n-type semiconductor. So there are two types of classification on extrinsic materials depending upon the majority charge carriers. Right? There are n-type extrinsic semiconductors and p-type extrinsic semiconductors. In n-type, we will be having electrons as major carriers. The n-type semiconductor materials are obtained by adding pentavalent atom to the pure semiconductor material. Okay, so if you take say bismuth, sorry, antimony, if you add antimony with the silicon, there will be a more number of, that is the pentavalent atom. Four electrons in the valence orbit will form bond with the silicon. Remaining one electron will act as a charge carrier. Okay, so the majority carriers in the n-type semiconductor materials are electrons. Similarly, obviously, you have minor charge carriers. Here we have holes as a minor charge carrier. Obviously, holes are present in some places. Okay, so while doping, obviously it will happen. In p-type semiconductor material, what will happen is you will be having a trivalent dopant. Okay, what happens if you had a trivalent atom with the silicon? There will be a vacancy for accumulating an electron there. So as a result of that, we will be having more number of holes. As a result of that, majority carriers will be holes in the case of p-type semiconductors. Minority charge carriers will be electrons, right? So this is what the classification of semiconductors are. Hope this video is very helpful to you and this will help you in revision. And in next video, we will discuss further more about the semiconductor materials, particularly p-n junction, okay, and the biasing concepts and the characteristics. Okay. Thank you so much. We will discuss some more concepts in our